Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos. Lesson 3. Metals and non-metals. Physical properties. Metals. Collect the samples of metals, iron, copper, aluminium, magnesium, sodium, lead, zinc and any other metal that is easily available. Metals, in their pure state, have a shining surface. This property is called metallic luster. Metals are generally hard. The hardness varies from metal to metal. Some metals can be beaten into thin sheets. This property is called malleability. Gold and silver are the most malleable metals. The ability of metals to be drawn into thin wires is called ductility. Gold is the most ductile metal. You will be surprised to know that a wire of about 2 kilometers length can be drawn from 1 gram of gold. Metals are good conductors of heat and have high melting points. The best conductors of heat are silver and copper. Lead and mercury are comparatively poor conductors of heat. Metals also conduct electricity. The metals that produce a sound on striking a hard surface are said to be sonorous. Non-metals. Some of the examples of non-metals are carbon, sulfur, iodine, oxygen, hydrogen, etc. The non-metals are either solids or gases except bromine, which is a liquid. It is concluded that we cannot group elements according to their physical properties alone, as there are many exceptions. For example, 1. All metals except mercury exist as solids at room temperature. 2. Metals have high melting points but gallium and cesium have very low melting points. These two metals will melt if you keep them on your palm. 3. Iodine is a non-metal but it is lustrous. 4. Carbon is a non-metal that can exist in different forms. Each form is called an allotrope. Diamond, an allotrope of carbon, is the hardest natural substance known and has a very high melting and boiling point. Graphite, another allotrope of carbon, is a conductor of electricity. 5. Alkali metals, lithium, sodium, potassium, are so soft that they can be cut with a knife. They have low densities and low melting points. Elements can be more clearly classified as metals and non-metals on the basis of their chemical properties. Most non-metals produce acidic oxides when dissolved in water. On the other hand, most metals give rise to basic oxides. Chemical properties of metal. What happens when metals are burnt in air? Magnesium burns in air with a dazzling white flame. Almost all metals combine with oxygen to form metal oxides. Metal plus oxygen is equal to metal oxide. For example, when copper is heated in air, it combines with oxygen to form copper 2 oxide, a black oxide. 2Cu plus O2 is equal to 2CuO. Copper 2 oxide. Metal oxides are basic in nature. But some metal oxides, such as aluminium oxide, zinc oxide, etc., show both acidic as well as basic behavior. Such metal oxides which react with both acids as well as bases to produce salts and water are known as amphoteric oxides. Al2O3 plus 6HCl is equal to 2AlCl3 plus 3H2O. Al2O3 plus 2NaOH is equal to 2NaAlO2 sodium aluminate plus H2O. Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to produce alkalis. Na2O plus H2O is equal to 2NaOH. K2O plus H2O is equal to 2KOH. All metals do not react with oxygen at the same rate. Different metals show different reactivities towards oxygen. Metals such as potassium and sodium react so vigorously that they catch fire if kept in the open. What happens when metals react with water? Metals react with water and produce a metal oxide and hydrogen gas. Metal oxides that are soluble in water dissolve in it to further form metal hydroxide. But all metals do not react with water. Metal plus water is equal to metal oxide plus hydrogen. Metal oxide plus water is equal to metal hydroxide. Metals like potassium and sodium react violently with cold water. 2K plus 2H2O is equal to 2KOH plus H2 plus heat energy. The reaction of calcium with water is less violent. Ca plus 2H2O is equal to CaOH2 plus H2. What happens when metals react with acids? Metal plus dilute acid is equal to salt plus hydrogen. Hydrogen gas is not evolved when a metal reacts with nitric acid. It is because HNO3 is a strong oxidizing agent. The reactivity decreases in the order Mg greater than Al greater than Zn greater than Fa. How do metals react with solutions of other metal salts? Reactive metals can displace less reactive metals from their compounds in solution or molten form. Metal A plus salt solution of B is equal to salt solution of A plus metal B. How do metals and non-metals react? A sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell now becomes the outermost shell, and that has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons has become 10, so there is a net positive charge, giving us a sodium cation Na+. On the other hand, chlorine has 7 electrons in its outermost shell, and it requires one more electron to complete its octet. If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L and M shells. This gives us a chloride anion C.1. So both these elements can have a give and take relation between them. The compounds formed in this manner by the transfer of electrons from a metal to a non-metal are known as ionic compounds or electrovalent compounds. Properties of ionic compounds. Physical nature. Ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. Melting and boiling points. Ionic compounds have high melting and boiling points. Solubility. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Conduction of electricity. The conduction of electricity through a solution involves the movement of charged particles. Occurrence of metals. At some places, minerals contain a very high percentage of a particular metal and the metal can be profitably extracted from it. These minerals are called ores. Extraction of metals. Some metals are found in the Earth's crust in the free state. Some are found in the form of their compounds. For example, gold, silver, platinum and copper are found in the free state. Copper and silver are also found in the combined state as their sulfide or oxide ores. Several steps are involved in the extraction of pure metal from ores. A summary of these steps is given in each step is explained in detail in these sections. Enrichment of ores. Ores mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, etc., called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The processes used for removing the gangue from the ore are based on the differences between the physical or chemical properties of the gangue and the ore. Different separation techniques are accordingly employed. Extracting metals low in the activity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar HgS is an ore of mercury. 2HgS plus 3O2. Heat is equal to 2HgO plus 2SO2. 2HgO. Heat is equal to 2Hg plus O2. Extracting metals in the middle of the activity series. The metals in the middle of the activity series such as iron, zinc, lead, copper, etc. are moderately reactive. These are usually present as sulfides or carbonates in nature. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. Roasting 2ZnS plus 3O. Heat is equal to 2ZnO plus 2SO. Calcination. ZnCO3. Heat is equal to ZnO plus CO2. Extracting metals towards the top of the activity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. These metals are obtained by electrolytic reduction. For example, sodium, magnesium and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, the negatively charged electrode, whereas chlorine is liberated at the anode, the positively charged electrode. The reactions are at cathode Na++ Ana, at anode 2Cl. Cl plus 2E. Refining of metals. Electrolytic refining. Many metals, such as copper, zinc, tin, nickel, silver, gold, etc., are refined electrolytically. In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode. A solution of the metal salt is used as an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Corrosion. Silver articles become black after some time when exposed to air. This is because it reacts with sulfur in the air to form a coating of silver sulfide. Copper reacts with moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. This green substance is copper carbonate. Iron, when exposed to moist air for a long time, acquires a coating of a brown flaky substance called rust. Prevention of corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing or making alloys. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. Alloying is a very good method of improving the properties of a metal. We can get the desired properties by this method. Brass, an alloy of copper and zinc, Cu and Zn, and bronze, an alloy of copper and tin, Cu and Sn, are not good conductors of electricity, whereas copper is used for making electrical circuits. Solder, an alloy of lead and tin, P, and Sn, has a low melting point and is used for welding electrical wires together.